It is a mistake to restore your database. Hopefully, that is somewhat of a inflammatory remark to talk about why restoring your database is perhaps a mistake. To help set the scene for why restoring your database is perhaps a bad idea, let's talk about the evolution of backup and restore. In the good old days, databases were small. They were tiny little things. And so you had a database and you had plenty of space in which to back it up. So you'd simply take a full copy of the database. And the next night, take another full copy of the database. If it only takes 15 minutes to back up, why not copy the whole thing? Grab another one, etc., etc. It was very easy to do backups. Before RMAN or even with RMAN, you simply grab the whole database, slammed it onto a backup target, and you're good to go. If you ever need to restore it, you just copy it back because the copying to and from was relatively quickly. And of course, what happened? Databases got big. That's what happened. And all of a sudden, they took a long time to back up. But more importantly, you could now fit maybe one onto your backup storage. But the moment you said, look, I need to copy 2 or 3, then that's a bit of a problem because no one gave you the budget to have those backups stored. And so we had some dramas there. What did we invent? Well, we started looking at incremental backups. And so, yes, we still have one big copy of the database, and we started heading into incremental land to actually take Monday, Tuesday, Wednesday as incrementals from, say, Sunday's backup. I would imagine that this is probably the most common thing you see. Even on our cloud databases, incrementals generally are the way we move forward. It's a very common strategy because we don't have the space for lots and lots of copies of our database. Hopefully, if you've attended some of my office hours sessions before, you're now using blockchain tracking, which simply doesn't change the paradigm, but it makes backing up those incrementals blazingly fast. And obviously, therefore, the time it takes to back up that one huge database becomes a very rare event, and your incrementals can just fly forward very, very quickly because of blockchain tracking. The problem is no one cares. No one cares if your backups are fast. And when I say no one, I mean your business users, your business customers. You might care because it's less load on your server, it's less fretful and downtime for you, but the reality is no one cares about backup speed. Where you're paid is, where your money is really earned as a DBA is when it comes to restoration. And the problem is, it doesn't matter how fast your backups are. When it comes to restoring, when you lose that primary database and your job is now to restore it, well, that's a big deal because first of all, you've got to pull that huge database back in place. And now you're paying the price for the benefit of backup speed. All those incrementals now have to be applied as well. You might be using differential incrementals, which avoids some of this, but still it's take a full copy of a database from some time ago and roll incrementals onto it until it comes back up to date. That's restoring, and I view restoring as a mistake because it takes forever. And every minute you're down during a restoration is where your reputation is being torn away at. No one cares that your backups are fast. What if we could have a database ready rather than doing backup and recovery? We could have a database ready to go. Now, don't panic. I'm not talking about Active Data Guard. I'm not talking about RAC. I'm not talking about anything which is going to cost you money. Everyone always freaks out when I say have a database ready. It's got nothing to do with having you give more money to Oracle. This is not going to cost you anything more. Rather than doing backups of your database, let's do some copies of our database. And really, it's just some very small changes to our scripts. Let's do a demo. As you can see, my backup directory is empty. We have no backups so far. This is what I'm going to do. I'm going to do a recovery of the database. And that seems weird because I'm meant to be doing a backup, but that will become apparent shortly. Now I'm doing a backup at level 1. Now, because we have no backups, the first one will be a full copy of the database. Let's see if this works. So as I said, the first thing is we're doing a recovery first, which does nothing. It says I have nothing to do to recover on. So we'll come back to that. I have no parent backup copy, which means I have no level 0 to work for. And so this first copy, even though it's level 1, is a full copy of the database. It's a very small database. That's why I created it before this demo started, such that we could back it up quite quickly. You can see that now we have some files in our backup destination, and it's just a very empty database. We got sysorg, system, undo table space, users, etc. Just the 4 data files in a default database. This one's non-pluggable to keep it nice and small. If I look at this, you can see the size of the files are pretty much comparable to the size of the database. I've got 500 megs for sysorg and 480 megs rounded down here in the database. So it's reasonable to assume that that is literally a copy of the data files. They are literally copies as opposed to backup sets. Let's go into RMAN again and run that same backup. This is the next day's backup. Once again, it does this thing. It tries to do a recovery and finds nothing to recover, which is correct. I'll come back to that in a second. Now I'm doing an incremental, and it's very, very fast because I have a full copy of the database to work with, and this is now just the changes. Once that finish is done, now I can see my backup folder. I've got the original full copy of the files, and I've got my incremental, which is only 130 kilobytes because I've changed very, very little. So I have a full copy and one incremental. Now let's run my backup script on the third day. Now here's where things get interesting. My recovery is actually doing some work now. If I scroll back up, you can actually see the recovery phase is actually doing some work. What it's doing is taking that incremental I just took, and it's rolling that incremental into the full copies of the files. That full copy of the database is now being rolled forward. And then it goes ahead and takes another incremental. So now you can see I've got my full copy of the data files. I've got my two incrementals, and this incremental has now actually been pushed into the full copy of the database. So the full copy of the database has actually been moved forward slightly as well. Let's actually do a little bit of work now to actually prove that this is working. I'll drop a couple of tables. I'll put some new tables in place. So I'm actually doing some work. I'm creating some objects in the database, and I can look at my SCN number on this database. It's 1957479. Now I go back and do my nightly backup. There's my users table space. It's currently at 8:52 p.m. in Perth time. And just to prove that things are actually happening here, I run my standard incremental backup. It rolls forward an incremental, and then it does another incremental. Now when I look at my users, it has moved from 852 to 853. So the file name of the full copy of the users database has moved forward. If I go look at Recovery Manager, I can actually see I've got some information there, but notice the checkpoint SCN is still lower than the one I actually queried. The other one was, I think it's probably gone, has it? Yeah, I scrolled it off. I think it was 1957 something. So my users table space is still old because I've rolled forward last night's incremental, not the one I've taken after I've created that table. So it'll actually be tomorrow night, the next incremental, that's actually going to roll those changes through into my users table space. So if I go into Recovery Manager and list out the SCN, now it's moved on to 1957. So it's picked up those two tables, T1 and T2. So what have I achieved here? Let me do that pictorially. This is what I've achieved. I took a backup and I took an incremental. I then took another incremental, but as part of doing that, I rolled the main backup forward. So that backup now is quite close to current point in time. When I took the next incremental, I used the previous one to roll that backup forward as well. So my full backup is not one from last Sunday anymore. It's always one that I can just go back, maybe just one worth of incremental. I'm shrinking that backup restore time down dramatically because I only ever have to apply one incremental. At which point you're saying, it doesn't really matter how many incrementals I have to apply. It's the cost of removing that whole backup and putting that back into place, that huge database. That comes back to this slide. If we can free ourselves from the concept of our file names have to be these pretty file names in pretty locations, that we just don't care where the database is, any file name in any location is a valid database, then backup databases, which are copies of the database, become very, very powerful. As I said, I've got this full copy of the database, which I've been rolling forward. Now I've had a catastrophe on my main database. What do? How do I restore that database? Because at the very start of this topic, I said, restoring is a mistake. Well, let's see what we do. I need to kill off my database. I'm simulating here that my main database has been fried. I'm just going to shut down abort, but let's say it's blown up, it's lost some data files, etc. I'm just going to kill it off, shut down abort. How do I restore it? What do I have to copy around? Well, here's the key. I don't have to copy anything around. I'm going to start up my database in mount stage because I'm trying to recover it. There's our database started. As I said, it's been corrupted. We've lost our data files. Do I have to do a restore? No. Because I have, let me scroll back a bit. Because I have this backup, which is literally a copy of the database, and it's a copy of the database that I have been rolling forward in time, there's no restore to be done. I simply say, switch my database to become that copy. The database is now the files that were on my backup location. It's now a fully fledged database. I can recover it, which simply says take the latest incremental and push it forward and open the database up. I'm done. There was no restore being done. There's no file copying going around. And in fact, if I now log on to my database, it's open and you can see the database files are actually now the backup files. I now take a backup. Where would I put this backup if I'm putting it here? Well, I would simply put it back in the original location. I would simply flip-flop over, assuming those disks are still valid for use. And so that's the benefit here. If I start using backup as copy and that rolling recovery mechanism, I actually don't need to ever do a massive restoration. Restoration can be considered a mistake. We just want to do database switches and database recoveries. It's blazingly fast. The other benefit of that is if you have sufficient disk space, then I can have one database which is only one incremental behind. I could have another database full copy somewhere, which is perhaps 5 days behind if I ever need to go back further than that. I could have one which was 10 or 15 or 20 days behind. So if I ever got to the point where I need to recover quickly to yesterday, I've got my standard backup. If I need to recover quickly to a week ago, I've got another backup, which I can go back to that one. Once again, just switch to copy. If I've got one which is a month old, I can switch to that one as well. So I can have a few copies kept at various points in time. All I change in my script is I say recover up until sysstate minus 14, recover until sysstate minus 30, etc. That's the only change in that script I have to do. The RMAN infrastructure will take care of rolling that forward just enough to keep it as old as I require it.